I am Tarun Kumar. Let's dive into Project Image Captioning.
Have you ever just scrolled through your phone and wondered how it can magically find a photo when you type dog on a beach? It seriously feels like magic, right? But it's not. It's all about teaching a computer to see the world, to understand an image, and then describe it in a sentence, just like you or I would. Well, today we're going to pull back the curtain and see exactly how that works.
So here's our game plan. First, we'll get a handle on what the challenge really is. Then, we're going to peek inside the AI's brain to see its two key parts. After that, we'll see how it learns from thousands of human examples, how we train it, and maybe most importantly, how we grade its homework. And finally, we'll zoom out and think about what this all means as we go from just pixels on a screen to something that feels a lot like perception.
All right, let's dive right in. What does it really mean for a machine to look at a picture and describe it? It all starts with a question that is incredibly simple for us, but, well, it's a huge puzzle for a computer. I mean, think about it. For you and me, it's second nature. We see a scene and the words just pop into our heads. But a computer? It just sees a grid of numbers, a bunch of pixels. The real trick is building a bridge between that sea of pixels and a meaningful idea like, say, a dog running on the grass. How do you even begin to do that?
Well, in the world of AI, this task has a name: image captioning, and it's really a team-up of two super powerful fields. First, you've got computer vision, which is all about teaching the machine to understand what it's seeing in those pixels. Then you bring in natural language processing, or NLP, which takes that understanding and turns it into a sentence a human can read. One part sees, the other part tells.
And this is the part that's so important. A simpler AI can be trained to just spot a dog and draw a box around it. That's called object detection. But image captioning is so much deeper. It has to grasp the relationships, the actions, the whole story. The dog isn't just in the picture, it's running, and it's running in the grass. That context, that story, that's everything.
So why do we care? What's the big deal?
Well, the real-world uses are pretty incredible. This tech can open up the visual web for people with vision impairments. It can automatically organize your photo library with thousands of pictures, so you can actually find what you're looking for. And it can even give a robot a much better sense of what's going on around it. This is seriously useful stuff.
So, how in the world does this work under the hood? The best way to think about it is like a digital brain that has two very different, very specialized halves. Each one has a specific job to do. Okay, the first part is called the encoder, but let's just call it the eye. It uses a really powerful vision model, a ResNet 50, to look at the image and basically boil it all down into a rich, numerical summary of its key features. Then you have the second part, the decoder. This is our storyteller. It's a different kind of model, an LSTM, that's really good with sequences, like sentences. It takes that numerical summary from the eye and starts writing the story, one single word at a time.
So let's walk through the flow. You start with an image. It goes into the eye, our encoder, which spits out that numerical summary, the feature vector. That vector gets passed over to the storyteller, the decoder. The storyteller looks at it and predicts the very first word of the sentence. Then, and this is the clever part, it takes that word and feeds it back into itself to help predict the next word, and it just keeps doing that, word by word, until it decides the sentence is complete.
But there's a little secret ingredient that makes this work so much better, something called an attention mechanism. Imagine you're describing a busy painting. You don't just stare at the whole thing at once, right? When you talk about the boy, you look at the boy. When you talk about the boat, you look at the boat. That's what attention does for the AI. As the storyteller is about to write a word, it glances back at the most important part of the image for that specific word. This ability to focus is a total game changer for getting accurate captions.
I'm Guna Varshit. Now move on to learning from human.
Okay, so we've got the brain, we know its structure, but how does it actually learn? You can't just program it with the rules of grammar and a list of objects. No, it has to learn from examples, just like a person does. It needs a classroom, and it needs a textbook.
And its textbook is a big collection of data. In this case, the Flickr 8K dataset. It's got 8,000 real-world images. But here's the key. For every single image, 5 different people wrote a caption. This is huge because it gives the AI a ton of variety. It learns all the different ways humans might describe the same scene, letting it see those subtle links between what an image looks like and how we talk about it.
Now, you can't just throw the textbook at the AI and hope for the best. There is a lot of prep work.
This is the not-so-glamorous part. You have to clean up all those human captions, standardize everything, resize every single image so they're all identical. This kind of careful data preparation is one of those behind-the-scenes steps that is absolutely crucial for any AI project to succeed. All right, the data's prepped, the textbook is ready. It's time to start the class. This is where the magic happens, where that digital mind actually starts to forge the connections between pixels and language.
So how do we know if it's actually learning? Well, we keep track of its loss, which is just a fancy word for its error rate. Basically, how wrong are its predictions? We run it through the entire dataset 20 times. Those are called epochs. And what we want to see is that error score go down, down, down. And as you can see from this chart, that's exactly what happens. That falling line is the sign of a good student hard at work. Now, once the AI is trained, it needs a strategy for actually writing a new sentence. The simplest way is called greedy search. It just picks the single most likely next word at every step. It's fast, but it can get stuck in a weird sentence. A smarter way is beam search. Think of this like exploring a few different paths at once. It keeps a handful of the best sentence starters going and then picks the best overall sentence at the end. It's a little slower, but the results are usually way more accurate and natural. Okay, the training is done. The strategies are in place. Now it's time for the final exam. The books are closed, so let's see how well our AI actually learned to describe the world. And check this out. Here's an actual caption the model came up with. Dog is running in the water. It's not Shakespeare, but hey, it's simple, it's grammatically correct, and it perfectly describes what's happening. It nailed the subject, the action, and the environment. That is a huge win. And remember that smarter beam search strategy we talked about? Here's the proof that it really works. We can measure the quality of the captions with something called a blue score. Just think of it as a quality grade. A beam width of 1, which is just that simple greedy search, gets a decent score. But look what happens when we let it explore 3 and then 5 different options at once. The quality score goes up each time. More exploration leads to a better result. So what was the final grade? The AI's final report card is a blue score of 0.218. Now, the way this score works is by comparing the AI's caption to the 5 different ones written by humans, looking for similar words and phrases. A perfect score would be 1.0. A score of 0.218 might not sound amazing, but on a tough test like this, that's actually a very solid result. It passed. So let's just take a step back and look at the big picture. We started with a really simple question, and we ended up with a whole system that can look at a photo and describe it in plain English. Let's just quickly recap that journey. I mean, think about what we just covered. We started with this really hard problem. We built a 2-part AI brain, an eye to see and a storyteller to tell. We gave it a textbook filled with thousands of human examples to study from, and we watched it learn, we tested it, and we proved that it could generate captions that actually make sense. A complete journey, all the way from pixels to words. And all of this brings us to one last really deep question. When this AI describes a photo, is it truly understanding what's happening in the scene? Or is it just an incredibly clever pattern matcher that's found statistical links between certain pixel arrangements and certain words? That line between real comprehension and just sophisticated matching is one of the biggest, most fascinating debates in AI today, and it's definitely something to think about. Thanks for tuning in.
I am Hashwant. My topic is Pixels to Poetry.
You know how your phone can sometimes describe a photo to you? It feels like pure magic, right? Well, it's not magic. It's this incredible process of teaching a machine to see and then to speak. Today, we're going to pull back the curtain and see exactly how that works, using a real project as our guide. We're going to break it all down.
All right, so here's the game plan. First, we'll tackle the main challenge. Then, we'll gather our ingredients. Yep, there are ingredients. After that, we'll look at the blueprint for the AI's brain itself. Then comes the really cool part. We get to go inside the classroom and watch it learn. And finally, we'll see if it passes the final exam.
So, let's start at the beginning. What's the fundamental problem we're even trying to solve here?
And really, it all boils down to this. When you and I look at a photo, we see a story, right? A memory, a feeling. But a computer, it just sees a grid of numbers. Pixels, that's it. So the real trick, the whole challenge, is how do you get a machine to bridge that enormous gap between a bunch of numbers and actual meaning?
To even begin to tackle this, we need the right ingredients. It's kind of like baking a cake, you know? You can't just build a powerful AI out of thin air. You need the right raw materials.
So, here's our recipe. First and foremost, you need a ton of images, but just as important, you need captions written by actual humans that describe those images. Then we use some tools of the trade, like the Python programming language and a popular AI framework called PyTorch to mix it all together.
Okay, so for this specific project, our key ingredient is a dataset called Flickr 8K, and it's pretty much what it sounds like, a bit over 8,000 photos. But here's the secret sauce. Every single one of those images comes with 5 different descriptions written by people. That's huge because it gives the AI a bunch of different examples of how to describe the very same scene.
And this is what it actually looks like on the inside. You've got a file name for an image, and it's paired with a sentence. The AI's entire job, its whole purpose, is to figure out the connection between the pixels in that picture and the words in that sentence, and to do that thousands and thousands of times.
Now, before our AI can even think about writing a sentence, it needs to know what words it's allowed to use. So we build what's called a vocabulary. It's literally like giving the AI its own personal dictionary. We make it read every single caption in the dataset and just count up all the unique words it finds.
So after it's gone through all those captions and we've tossed out the really rare words, the AI's final dictionary has just under 3,000 words in it. That's it. Those are the only building blocks it has to work with to create every single description.
Okay, we've got our ingredients. Now we need the blueprint. We have to actually design the AI's brain. And it's not just one big thing. It's more like a team of 2 different parts working together.
First up is what's called the encoder. The easiest way to think about this is, it's the AI's eyes. It's a special kind of neural network, a CNN, that's just brilliant at image recognition. Its entire job is to look at a picture and basically make a list of what it sees. You know, dog, green grass, blue water, all the key visual stuff.
Then that list of features gets handed over to the second part, the decoder. And if the encoder is the eyes, the decoder is the AI's voice. This is a different type of network, an RNN, and it's really good with sequences, like sentences. It takes those concepts from the encoder and starts weaving them into a sentence, one word at a time.
So here's how that whole system works together. The image goes in, the encoder sees it and pulls out all the important features. Then it hands those features over to the decoder, which then speaks the final caption. See? It's this simple, really elegant partnership, eyes and a voice, working together perfectly. So, we've built our AI. We've designed its brain. Now, it's time to send it to school. This is the training phase, where all the learning actually happens.
A word you're going to hear a lot is epoch. All an epoch is one complete pass through the entire training dataset. So the AI has seen every single image and caption exactly once. It's like studying a textbook from cover to cover. And just like us, to get really smart, it's got to read that textbook a few times.
Okay, but how do we actually know if it's learning anything? Well, we track something called loss. Just think of it like a grade on a test. It's a number that tells us how wrong the AI's captions are compared to the real human ones. So a high score is bad, means it's way off. A low score is great. The whole goal is to get that loss number as low as we possibly can.
And here it is. This is the AI's report card. This graph shows the loss score over 20 epochs, so 20 times through the textbook. What you really want to see is that downward trend. The line is going down, which is exactly what we want. It's visual proof that with every pass, the AI is making fewer mistakes. It's getting smarter.
All right, training is over. School's out. Now it's time for the final exam. We're going to show our AI a bunch of photos it has never ever seen before and see how well it does.
This really is the moment of truth, isn't it? Does all that learning and studying actually pay off? Can it do the one thing we built it to do? Let's find out.
So to get the best possible captions, the AI uses a clever trick called beam search. Imagine the chess player thinking a few moves ahead. Instead of just picking the one most obvious next word, it explores a few different sentence paths at the same time to see which one turns out best. And as you can see here, the more paths it explores, from 1 to 5, the better its final score gets.
Now for the results. Let's look at some examples. The one on top? That's amazing. It's almost a perfect match for what a human wrote. But then look at the bottom one. You can see its limitations. It got the man in red part right, but then it got stuck.
Let's zoom right in on that second one, because this is pretty interesting. You see those weird tags? That first one, unknown, that basically means unknown.
It's the AI admitting, hey, I see something here, but I don't have a word for it in my little dictionary. And the second one, end of sentence, that's just end of